This is an excellent question. Determine, so we're looking for stationary points and then greatest and least values. Very good. So I think a more common, this is very similar to optimization if you ask me. I've not seen as many of these in the past papers, but yeah, if you can do this, if you can do optimization, but to do this, it's just kind of going through the motions, right? So let's do the first one, the x-coordinate of the stationary point of the curve with this equation. So when you see phrases like stationary point, you should be thinking to yourself differentiation, because if I've got a curve, so say I've got this curve here, there are various gradients. I've got positive gradient, positive, 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 and then when you get to your stationary point, your gradient is equal to zero, a flat line, yeah? Gradient is equal to zero. Again, that's positive, 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 negative, 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 positive, positive, positive. And to get those gradients, we use our differential equation. So I'm going to have to set my differential up. So let's see, y is equal to 6x take away 2. And I'm going to rewrite this. Don't forget that means there's a little 2 here. So x to the 3 stays where it is, and the 2 goes underneath to make a little fraction. Okay, so that's been set up so I can differentiate. And I also remind myself what happens when I differentiate. So x squared becomes 2x. Because I multiply these two terms, the 2 and the 1 becomes 2. Take away 1, that becomes 1. And we're lazy mathematicians, we don't write the 1, but there it is. So I always use that. Use whatever you like, but just to remind you, because I guarantee when you're doing integration and differentiation, especially when they're quite complicated fractions, you will make a little mistake. So just get it clear in your head what you're doing. Now I've got a y equals, so I'm going to use my dy by dx. So 6x becomes 6. Yeah, you lose your x, because that's x to the 1, so it becomes x to the 0, which is 1, so yeah. And I'm going to multiply these two terms, so 2 times 3 over 2. Now, if you're not great at that, just write it on the side. 2 times 3 over 2, so your 2's cancel out, and you're left with 3. So that's going to become 3x, and you've got 3 halves. Take away 1, which is 2 halves, so that's going to be 1 half. So I've now just differentiated my formula. And I need to find the x-coordinate for the stationary point. So at that point I would say, okay, well, dy by dx is equal to 0 for stationary points. And then I'll say 0 is equal to 6, take away 3, and I'm going to call it root x just now, just because I think it looks nicer at this point. I'll say maybe I'll regret that, but I'm just going to write it like that. And okay, can we solve that? Well, right now I think all we can do is take out a common factor from both those terms of 3. So that's going to give me 2 take away root x is equal to 0. So my solutions for this, there's no solution here. But this is saying 2 take away root x has to be equal to 0. So it means that 2 has to be equal to root x. So 2 is the square root of what? Well, square both sides, you can do it that way if you want. 4. Okay, so x is equal to 4. I'm just going to write it on that side. X is equal to 4. So I've got one stationary point at x is equal to 4. You might have had multiple stationary points here, but yeah, so far I've just got 4. So marks for that, you were getting a mark for rearranging so you could differentiate it, well, rewriting, not rearranging. And then you were getting a mark for differentiating one term and then completing the differentiation and putting it equal to 0. So I'm going to say a mark for this and a mark for this, and then a mark for your final solve. Okay, so rewriting it was 1, and then differentiating one of your terms was getting you a mark, and then finishing off the differentiation, putting equal to 0, and solving. So not bad, for 4 marks. And now it's saying determine the greatest and least values of y within this interval. Okay, so for this, let's think about it. The greatest and the least. So I've got a function, maybe this is the function here, and x is between 1 and 9. Now, if I was looking at this one, maybe that's 1 there, and that's 9 over there. So if I was putting 1 and 9, I would actually get the 2 of the very highest values in the graph, but I'd miss out on the lowest one because there's a turning point here. And that's what you have to do with this. You want to put in your max and your min for your equation, and then also see if there's any turning points in the middle and check what their value is as well. So the first thing I'd do is substitute in. So I'd say, well, x, when it's equal to 1, is going to give me y is 6, 1, take away 2, and that's the square root of 1 cubed. So that's 6 take away 2, so that's going to give me 4. So when x is equal to 1, y is equal to 4. That's my first bit. And then do the same again for x is equal to 9. So you're doing it for your highest and, well, for not the highest levels, but the two extremes of your equation. So 6 and 9 take away 2, the square root of 9 cubed. So 6 nines are 54, and I'm going to take away from that. Square root of 9 is 3, and 3 cubed is 27. 27 times 2 is going to give me 54. So 54, take away 54, going to be left with 0. So when x is equal to 9, y is equal to 0. So that's when you got my two extreme values. I've got 4 over here, and I've got 0 over here. Okay, and then I'd like to work out what happens at a stationary point, because that, like we're saying here, it's not a linear equation. It's not like putting the lowest x and the highest x. It could fluctuate in there. It could fluctuate twice. If you had two stationary points, you'd have to check them both out. But the stationary points are the extremes within that line. Yeah? So I'll just check it again, and I'm going to check it for when x is equal to 4. So I'll just say x is equal to 4 at stationary point. And let's substitute that in. So y is equal to 6, and 4 take away 2, square root of 4 cubed. So that's 24, take away 2 times, square root of 4 is 2, 2 cubed is 2 times 2 times 2, so that's 8, times 2 is 16, so that's going to give me 8. So that's my range of different values inside of this interval. So what do we say then? What's the maximum and what's the minimum values then? Well, it looks to me as if the maximum is 8. Maximum is equal to 8, and the minimum is equal to 0. That's the minimum there. And you could just say, if you wanted, that's when x is equal to 9. And for 8, that's when x is equal to 4 at the stationary point. It doesn't ask about the nature of these things. If it was asking about, where does this occur and what's the nature of that turning point, you then have to do like a nature table or a double differential if you wanted. But right now, all it's really trying to get you to do is visualize this this curve. And we've said, well, I've looked at my two ends of the curve, but what's in the middle? Well, the extreme in the middle will be the stationary point, so you need to work out the y at that. So it really, for 3 marks, it's actually 3 marks for substitution when you think about it. So in the marking scheme, you're getting a nice little mark for 8 in here. You're going to mark for your 4 and your 0, and then a mark for your final answer. So actually not a bad 3 marks, but it doesn't come up very often, this question. I've not seen it as often. I'm glad we might have a chance to go through it. Like I said, the only other thing that might come up is if there was maybe 2 stationary points. Pardon me, you'd maybe have to state the nature of them. That might be clear in the question. But yeah, put in your 2 extremes, and then again your other extreme, which is the stationary point. Yeah, I hope that's helpful.